Welcome! Today we are going to learn how to order rational and irrational numbers. If you see this picture here, it's a gentleman ordering an irrational number with the side of a rational number. Ha 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 ha. Moving on. You might see a problem that looks like this. Put these in order from least to greatest, and then you have, it looks like there's a mix of rational and irrational numbers because that's a terminating decimal. We remember that means that it's rational. It could be expressed as a ratio. That's an integer. -1 is an integer, so that's a rational number. Square root of 18. Is 18 a perfect square? Nope. So this is going to be an irrational number. Negative the square root of 4. I like this one. Is that rational or irrational? Before we go any further, let's think about that actually. Negative the square root of 4. What is the square root of 4? Is 4 a perfect square? Is there something that when you square it is 4? 2 squared is 4. So, if you take the square root of 4, that's going to end up being 2. But you have a negative sign on the outside. So what that ends up meaning is this is going to be equal to negative square root of 4 is 2. It's equal to negative 2. So negative the square root of 4 is equal to negative 2. Now, in order to order these sorts of numbers, let's actually, use a tool that lets us see order of numbers, like a number line. Ha! Alright, so let's put some of these values in place. We have 2.5. Easy to find on a number line. It's in between 2 and 3. Here you have it. 2.5. The next number is -1. This is even easier to find on a number line because it's already labeled for you. Now, granted, when you're doing this, you might actually have to draw the number line out, which is much more troublesome than just, taking a template from the computer and using it. But, we'll cross that bridge when we get to it. Square root of 18. We're going to hold on to that number for a while because this looks like it might be a weird number. So let's do this negative square root of 4. We already said that was going to end up being -2. So we have it right here and we're going to write it in its original form. Negative the square root of 4. Now all that's really left in terms of ordering is just where the heck that square root of 18 goes. How are we going to figure that out, where that goes? Well, let's use the go-to tool for answering questions about what the value of something is when we don't want to compute it in our head or on a piece of paper with a pencil. What would that be? That's right, your calculator. So let's take a look at the calculator to figure out what exactly the square root of 18 is. Now, this is not an actual calculator, so therefore it's not going to work. But let me tell you how to do it using your TI 108, because these are the calculators that you see in class. I think there is a calculator on here, and you'll just have to take my word for it. But let me tell you how you would type this into your calculator. Here's what you would hit. You would hit 1, go away, 8 for 18, and then an 18 will display up here. Once you hit 1, 8, and you have your 18 displaying, you then hit this little button right here, which is the square root symbol. So you actually have to, even though this is the square root symbol first and then the number 18, in order to type it into your TI 108, you have to type the number first and then the square root sign second. It's weird, but that's the way it is. Hitting that square root sign automatically takes the square root of whatever number is showing in the display. So if you hit 1, 8 and then the square root symbol, you would end up getting a number that was a non-terminating, non-repeating decimal because we knew it was going to be irrational. And the number ends up being, well, I don't know off the top of my head how many numbers your calculator holds, but mine ends up being, let me get a pen out. Mine ends up being 4.24. If you want, you can try this with a calculator at home or the scientific one if you have one on your phone or if you have one on your computer or tablet or whatever it is that you're using to watch this. You can try it out, see what you end up getting. This is what I get, and mine stops after 7. So I get 4 point, and that is a 4. 4.2426407, and this would end up, this is a number that doesn't ever stop. It just never stops. But for the sake of this particular lesson, we don't need to, we're not rounding to a certain point. We just need to know where this goes on the number line. So we can go back to our number line and say that, well, if it's bigger than 4, it looks like it's about 4 1/4. So we're going to call it 4 1/4, about maybe right there. Okay, so that's approximately, you're not going to get an exact answer because there is no exact answer to this. Not that we can write, because we'd be writing forever. So this is approximately square root of 18. And they wanted it, and this is, kiddies, you got to pay attention here. They wanted it from least to greatest. That's a very important thing. If they wanted it from greatest to least, it'd be a different answer. But they want from least to greatest. That means they start from here, and they want you to go in this direction on the number line. So that would be our first, the least. That would be our second, the second least. That would be the third, and that would be the fourth. All typed up in neat like it looks like this. Negative square root of 4, negative 1, 2.5, and the square root of 18. So we can now order numbers that are both rational and irrational. Using the number line and using our calculators to approximate the decimal equivalent of our irrational numbers. So that's a strategy. Find the decimal equivalent of irrational numbers and compare them to rational numbers. This also applies for fractions. If we were to say instead of -1, this was -1/2, we could still find the fraction, the decimal form of that, which would be -0.5, and we would use that on the number line. So using number lines is nice if you can convert everything to a decimal, because our number lines are I mean, we see them in terms of whole numbers and the spaces in between whole numbers like decimals. So the reason we don't want to use fractions on a number line if we're trying to compare them is just because, remember, that an irrational number cannot be written as a ratio. So you're never going to put an irrational number in fractional form. Because of that, you want to make something that they can all three be related to. So your whole numbers, your fractions, and your irrational numbers can all be expressed as decimals. So that's the strategy we use. Find decimal equivalents of all of your numbers, the rationals and then the rationals, and then compare them. Okay, now I challenge you with that information. Do you think that you could order these numbers without using a calculator, which means that you will not know the decimal equivalent of that irrational number and that irrational number? Would you be able to do that? Think about a strategy you could use in order to figure out how you would order these numbers without using a calculator. And what I want you to do, if you think you got it, bring it into class tomorrow, and we'll talk about how would you end up ordering these numbers without a calculator.